Okay, we discussed about the idea of interest, compound interest. Now we will discuss the idea of annuities. Fancy word. Annuities is simply a person putting in money into an account, and he's putting it in for a while, and just the end of certain amount of years he sees how much he has there. So obviously the money puts in earlier grows more, and money put in later grows less, and if you add them all together you find out the total amount of money he has. So this is what's called a geometric series, and we just simply use some formula to find out how much money we'll have in the end. Same question can be asked vice versa. Like everything in mathematics, you can ask two ways. So here we ask it differently. The different way of asking the question is not you put in $1 each year, how much will you have at the end of 10 years, but rather the question is asked if you take out $1. Actually, you can ask questions in a few ways, so I'll say all the ways. So again, one way the question is asked, I put in $1 every year, how much will I have at the end of 10 years? Another question was asked, how much do I have to put in every year for 10 years in order to have one full dollar? It's also a nice question. Also, you use a geometric series, you just fool around a little bit with it, but it's a little bit the opposite kind of question. Then there's another question that can be asked. If I take a loan of $1 today and I want to repay it for the next 10 years, how much will I have to pay each year to repay this loan of $10? I'm sorry, of $1. Now, to repay a loan of $1, you'll have to pay more than 10 cents each year, because since there's interest, so your 10 cents that you pay on the 10th year is not worth 10 cents. You understand that? Just get the general picture that if you take out a $1 loan, you'll end up paying a little bit more than 10 cents a year to repay your loan if you want to make 10 installments. And finally, the last question would be, if you are willing to pay $1 a year, that's how much money you can afford, how much loan can you take out? So again, you cannot take out full $10, only $9 and something, or $8, depends on the interest rates, because as we said, that since there's interest, so you pay more than the money that you took out. So if you take out $8, you can repay it by paying each year $1. So this is the four sides of the coin. To understand the whole idea of annuity, just every question that's asked in the textbooks or in the practice exams, just have to understand what is being asked. Is asked if you put in $1, how much you accumulate. And again, the question can be asked in two ways. If you put in $1, or if you want to have $1 accumulated, how much should you put in? And then the other two questions can be asked not on the future, just on the present. In other words, you are taking out a loan, $1, how much do you need to repay for the next 10 years to pay your debt? Or if you're ready to pay $1 each year, that's how much you earn and you can afford, how much money can you take out right now? So these are the four questions, and every question you just need to think a drop to see where this question, to which category it belongs, to the accumulated, or to the they call it the present value, that's a fancy word of it, And there's two kinds, as we said. This present value can be asked in the form of you're ready to repay $1, or you're taking out $1 loan. And then there's a final twist that you could ask also, that this you cannot solve with the ordinary calculator. And the old textbooks, they didn't expect you, they use different techniques. And since they force you today, the guys of the actual exam, they force you to use a certain calculator, so they can have this liberty to ask you a question that will work like this. If a guy puts in $1 today, and today, let's say from a year from now, that's already difference between due and immediate. If you put in $1 now, or you put in $1 a year from now, and you do this for 10 years. And I tell you that you will accumulate, you will have in the account at the end of 10 years, you will have $15 in the account. What is the interest rate? So he's giving you the final number is $15. You put in $1 a year. So basically, what it is in the language of mathematics, you need to solve for the exponent, because it ends up, as you know from the textbooks, it's you put in the rate. I mean, you need to solve for. I'm sorry, I didn't say correct. You need to solve for x. So I'll explain what it means. The way I'll put on a piece of paper what you need to solve for, and that's why you understand why you cannot solve this with a calculator, with a regular scientific calculator. You need to have this special calculator that has a built-in program for calculating this. So what you need to solve is like this: 1 plus I is the interest rate, to the 10th power minus 1 over I is equal to 15. I'll put it on the screen, you see what I'm talking about. This thing here, 1 plus I to the 10th power minus 1 over I is equal to 15. That means that if you put in, this formula is for accumulated value of $1 for the next 10 years, and I'm telling you you'll have $15 in the account by the end of 10 years. What is I? What is the interest rate? So as you see, you can fool around as much as you want. You can multiply by I both sides, so you get 15I, 1 plus I to the 10th minus 1 minus 15I. I'll write the formula here in a more compact form, and you'll see you still can't solve it. 1 plus I to the 10th minus 1 is equal to 15I. So you can write it again: 1 plus I to the 10th minus 15I minus 1 is equal to 0. Take a look at the two lines in the bottom. 1 plus I to the 10th minus 1 is equal to 15I. That's just by multiplying I both sides. Or you can write it in a quadratic form: 1 plus I to the 10th plus 15I minus 1 is equal to 0. So this is a typical example of a quadratic equation that goes up to the 10th degree. And you cannot solve it only if you have special methods. So this is the end of this video, and I hope you understand what I'm talking about.